Note that in your book, a statement of the form no x is y is defined as for all m in the domain, xm implies not ym. So I can use that to my advantage to negate things like no good car is cheap. First of all, no good car is cheap is an example of a universal statement, and if I want to reinterpret it using the definition from the book, I could write something like this. For all x in the domain of cars, if x is good, then x is not cheap. So in symbols, this would be written like that. Therefore, the negation of the for all statement is going to be an existential, and the negation of the if then statement is going to be a conjunction, an and statement basically, with the second part being negated. So to simplify the expression, we end up with there exists an x in the domain of cars such that, that's what this symbol stands for, such that x is good and x is cheap. So in other terms, what we're saying is that some car is good and cheap. Finally, in this section, we talk about the truth sets. What is a truth set? If p of x is a predicate and x has the domain D, the truth set of p of x is the set of all the elements of D that make p of x true. So in other terms, it's the numbers inside of the domain or the values inside of the domain that make your predicate true. We call that the truth set. And there are times when we write the truth set as D with the little p on the bottom in the index position to talk about the truth set of the predicate p. So for instance, if the predicate is q of n, and q of n stands for n is a factor of 8, then the truth set depends on the domain that I'm in. If my domain is the set of positive integers, then what would the truth set look like? Well, if the domain is all positive numbers, 1, 2, 3, 4, that are integers, then the numbers inside of that list that make my predicate true are going to be the numbers 1, 2, 4, and 8. So that makes the truth set of the predicate q of n. And we write the subset q, or subindex q, that represents the truth set of the predicate q. So it's the numbers inside of the original set, the domain, that make the predicate true. And the numbers 1, 2, 4, 8 are all factors of the number 8. Here's another example. Suppose I want to find the truth set of 6 over d is an integer, given that the domain of d is the set of integers. So in other terms, I want to figure out which numbers I can put into here so that the result is an integer. And the numbers that I'm allowed to pick from are themselves integers. So I can pick any of the integers, negative, 10, negative 9, and so on and so forth, all the way to positive infinity. I can pick any integer I want. And my goal is to figure out which numbers in that list make the predicate true. The numbers in the list that make the predicate true are the numbers 1, 2, 3, 6, and negative 1, negative 2, negative 3, and negative 6. Therefore, the truth set is going to be exactly those values.